Here we have a 100 kilogram mass that is sliding along at a constant speed of 5 meters per second. All of a sudden, it hits a rough patch and it slows down and stops in 2.5 seconds. So, if the force of friction is 200 newtons, find the work done. So, we're looking at the work done essentially here by friction. So, we need to acknowledge some sort of direction system here. So, we're just going to say that positive values are in the direction of motion and negative values are opposite the direction of motion. So, of course, our velocities are in the direction of motion. So that would be forward, for example. Our v2 is 0. The total time it takes is irrespective of direction. And then lastly is this force of friction. It's the only force acting, so we're just going to call it F. It's against our direction of motion, so it's negative 200 newtons forward or positive 200 newtons backwards. So let's take a look at what we need here. So we know that work is equal to force times distance. We know that distance is equal to your average velocity times time. So we're going to start off by solving for average velocity. So step one is solve for VAV, which is just your first velocity plus your second velocity divided by 2. So that's 5 meters per second plus 0 meters per second divided by 2, which leaves us with 2.5 meters per second. So that's step one. Step two here is to find the total distance or displacement because we need that to calculate the work done. So our displacement in this case is going to be our velocity times time. And I have 2.5 meters per second. That's in the direction of motion times 2.5 seconds given to us from the question. So that leaves us with a total displacement of 6.25 meters. It's positive, so that's in the forward direction. Now we're finally in a position where we can solve for work. So work is equal to your force times your displacement. You should recall that even though F and D are vectors, your work is actually just a scalar quantity. So we have negative 200 newtons from the work from the force, and we have 6.25 meters from the displacement. That's going to leave us with negative 1,250 joules of work.